So solvation refers to the way that solvent particles dissolve solute particles. The process is different for different types of solutes and solvents. So just to be clear about that, when I'm referring to different types of solutes and solvents, when it comes to solute particles, those different types would include ionic particles, polar molecular particles, and nonpolar molecular particles. And for solvent particles, there are only two types of, two different classes of particles we're going to talk about in here, and those would be polar molecular and nonpolar molecular. So we'll first take some time and talk about how ionic particles are solvated by polar molecular particles. Okay, so our solvent is going to be ionic. Our solution, or the solvent is going to be some polar molecular particle. Okay. Just to remind you about the structure of ionic compounds, let me give you a title for this first. Ionic compounds are made of oppositely charged particles, but that doesn't mean a 1 plus and 1 negative charge all the time. Some positive ionic particles, cations, would include the sodium ion, which has a 1 positive charge, a magnesium ion, which has a 2 positive charge, and a scandium ion, which has a 3 positive charge. We also have polyatomic cations like ammonium. NH4 has a positive charge. And all of these are types of cations. And then we've got the anions, the negatively charged particles. They include things like chlorine, which has a 1 negative charge. Sulfide, or chloride rather, would have a 1 negative charge. Sulfide has a 2 negative charge. There are polyatomic ions like sulfite, which has a 2 negative charge. And then phosphide is an anion that has a 3 negative charge. Okay.
What's the one after CO?
Sulfide, S with a 2 negative charge. And then sulfite, 2 negative, and phosphide. So all of these particles here, for the purpose of our illustration I'm about to do, I'm going to represent these as simply plus charged particles. They are all positively charged particles, and all of these are negatively charged particles. So the illustrations I'm going to do now, you need to remember this, that when I say they're I'm going to give you sort of a general idea of the way that some of these work. When I just say a positive particle, I mean it could be a positive 1, 2, or 3, or anything else positive. When I use the negative particle, it could be any one of those types of charges. Okay? So this symbol then right here. Do you have your pass from the nurse?
In the trash.
I need it back, please, and I need you to sign in and out.
Sorry, I'm not digging in the trash. I can't dig in the trash. Why you want me to dig in the trash?
Is it in that trash can right there?
Yeah.
Then get it out. All kinds of positive ions. And if you remember the term we used for positive ions, those were cations. And these symbols here represent this symbol represents all kinds of negative ions, and remember those were called anions.
But keep putting paper in the trash.
Well, can I go in there now?
In a minute, sure. All right. So ionic compounds then structure themselves so that they're next to each other, so that the opposite charges are next to each other. But it doesn't stop there. Okay? This negative particle is still attracted to more positive particles. And this positive particle is attracted to more negative particles. And this process continues. And this is how crystals grow, if you will.
I see somebody erase it.
Now, I've drawn this illustration. Remember, this is representing any kind of positive particle or any kind of negative particle. I've drawn this illustration so far in 2 dimensions. Side to side here is 1 dimension, up and down is 1 dimension, but front to back I'm not showing yet. So let's just kind of show it like this, like there's more of these particles stretching back behind here. Okay. You get the point? And so we're forming what you can call an ionic crystal. So what we're going to look at is how a polar molecule can dissolve a crystal like this. Okay? Now let's remind ourselves about polar molecules. Polar molecules are molecules that are where the atoms inside the molecule are bonded together covalently, but they're arranged in a way so that you have one end of the molecule that's more negative and one end of the molecule that's more positive. So we've got a partially positive end and a partially negative end on the molecule. So this represents a polar molecule. Wait a minute, I can't spell today, can I? M-O-L-E-C-U-L-E. Gracious. Molecule. All right? And the most common solvent that's polar, we use water all the time. Water is very polar. And if you can remember that water has an oxygen and 2 hydrogens, polar molecule. So if we were to draw, we've drawn water molecules like this, H, O, H. Okay, we said it was a bent molecule. When we did the 3-dimensional shapes of it, we also had lone pairs on here. Okay. But when you include the electron cloud with the shape of the molecule, the water molecule actually looks more like this. Okay, so this is the oxygen end of the molecule down here. And the hydrogen end of the molecule is up here. Remember the hydrogen end up here is the partially positive end, and the oxygen end down here is the partially negative end.
They look like that fall about that.
Hermit.
Kermit the Frog.
This line.
But they say fall after.
After being hit after.
Oh, after.
Okay.